Welcome to my shop. Today we have an Aphex Compellor, it's a model 320D. This one is not marked, I don't think, for date, but it's the D model, so it's got the digitals, so it's relatively new as far as these things go. And the complaint when it came in was that the lights flashed. And so I started looking at it, and I kind of started to take it apart here. I just basically took the lid off, that's all I did. And while I was doing that, unscrewing the screws in the side, I realized that if we turn this thing over, it has a little sticker right there. 240 volts, 50 to 60 hertz. So I looked in the manual and I said, how do you change that? And well, it doesn't say in the manual, but then I looked a little closer to the device and I found that in the back here, right here, if you can see that, little board right there with a hole in it. If we pull that out, you see that it has some writing on it, and the 240 is the right direction. So what we do is we turn it around so the 120 is in the right direction. The other side has 220 and 100. So we're going to stick it back in here. It's a tight fit, let me tell you. I like it when they do this, though. It's really nice. Alright. That is seated good. So let's see what happens. I've got it hooked up to my current limiting isolation transformer, and we'll plug her in up, okay, and we'll turn it on and see what happens. It's in test mode, so here we go. We're drawing 17 watts. That seems kind of high. Okay, that works. Yeah, but some of this doesn't look right. It's well, we've got no input. Let's turn it off and get a cable here. Okay. We'll plug that into there, and we'll plug that one in there. We'll just do it on this channel for now. Wait, that's analog channel 2. Let's just do one because it's one. Leave our level at +4. Okay. And turn on the frequency generator, audio frequency generator, and turn it on. Well, we have process. You can see this. Huh. Seems to be working. Wonder what the output looks like. There. Okay. So let's take the output and plug it into the scope. See what we got. What it looks like. Volts per division, time. Okay, The scope just sort of stopped. Why did it stop? Sort of making up its mind, I guess. Too many points. Oh. There we go. I had this thing set up for something else. Okay. So, what do we got? Well, let's find out. Let's take a look at the scope here. And it looks like we've got right at 1,000 hertz. Wow, really close with about 2.8 volts peak to peak. No, that's amplitude. I don't have this thing. I had this thing set up for something else, but anyhow, we got voltage and we got output. Let's see if it changes. Yeah, it changes. I'm doing the input level right now. There's the compression. There's the output. So basically, it appears to be working. Well, you always check voltages to make sure everything is fine. So let's see, if I remember correctly, pin 3 of H2 over here is ground. Lights are lit, that's all good. Let's take one of these guys. Let's see what we got. 30 volts plus that one's negative. Okay, pin 8 on this one, so about 30 volts. Let's go. Yep, across the chip we got 30 volts. Well, that's good. Let's check our regulators. Our first regulator here is minus 15 volts. Actually, plus 15. There's plus 15 volts. And this is the 5 volts. So that's in. Whoa. There's in 23.9. There's ground is 15, and out is 20 volts. Whoa. Turn it off. 7805. Well, let's look at the schematic. What the heck is this? U3 is a 7805. And it's supposed to have why would 7805 have 15 volts on it, or 20 volts, 15 volts in the center? That doesn't make any sense. Okay, hold on. I'm going to take this little board out of here. I'll be back in a minute. Okay, we're back. I got the little board out. It's kind of a pain. You got to take one of these main boards out here to get to it, because the little ICs, or the voltage regulators, are marked down to the board here. So what we got on here is we got a 7805, a 7915, and a 7815, just like it says in the manual. And it looks like, yeah, somebody has been playing around in here. I don't know who, or really care. But the capacitors have not been changed, so we'll check those just because they're old. I mean, you know. But if we look right there, you can see, looks like somebody's been soldering on it. Not so much on the bottom. Interesting. Well, what we want to do is we want to take the meter here, because it looked like it was shorted or something. I don't know. Weird. So let's take a meter. Five and 0.9 and 2. Well, wonder what a 7805 is supposed to look like. I don't know. Right off the bat. But let us. Are you a 7805? Can't see it. Wow, I need to clean these really bad. Yeah, there's 7805 P plus. So let's measure this and see what we got. We're just going to do this volt. Okay, so from left to center, I should have about 2.5. Left to right, 2.6. On this one, left to center, I got point something. Is it shorting out though? Let's see. 1.6 and a capacitor, but better, more than that, I got 0.5 volts across ground and output. But that might be because it's in circuit. No, that's normal. Okay, so are they using that 7805 as a regulator for a higher voltage? With 15 volts on the ground side, okay, so they got running it just like the 7815. I don't. That's interesting. I mean, what? Interesting. I really wish this thing had a rotate counterclockwise. Okay, let's see. 103 is the VCA, and VCC is 15 volts. I wonder if they're only using that 5 volts. Wonder where they use it at. Where's the power input? Let's see, the power input is going to be over here on HD. H103. So if we go down here and look, 101, 102, 103, plus minus 15, logic ground, audio ground, and pin 4 is supposed to be plus 5 volts. So on our power supply, which is down here. Pin 4 is tied to, no, well, pin 4 is supposed to be 5 volts. That's interesting, and that's the only place that that pin 4 goes. So this pin 4 is ground, 3, 4, and 5 are all ground, 4, 3, and 5 are ground, and pin 4 on H4, pin 4 on H4, which is right there, should be 5 volts. Why? It's just a little confusing. I'm sure it's the way it's supposed to be, probably, with my luck. But let's see, this guy here, so that's pin 4. So pin 4 should be connected to ground of, so pin 4 shouldn't be connected to anything but, yeah, right there. So this is the input, 1, 2, and 3. 7805 is in, ground, out, right? Yes. Yes, it is. So when this is connected, let's take a connection over here. So I've forgotten which one's which now. So this guy goes over here. Alright, well, so we'll go back here. So 3 and 4. And this one's got an H5. Ha! So this unit has an H5, which is the power supply for the digital board. So that one would be connected to there. Yeah. All right. Let's wonder if somebody unplugged this and then didn't plug it back in correctly. Let's and was back feeding that thing the voltage, because the chip looks okay. This is a pain to get in here. All right. All of these, of course, are isolated because all of the 15s and 5s and all those, the center tap is ground usually. What about the 15? I know it is in the 5. So it's isolated. It's got these little plastic washers with a little shoulder on them that goes down through the hole, and it keeps the Yeah, it keeps the keeps the screw from hitting. There was Loctite on these, and that's always special when you're trying to get the nut back on. Makes it at least a two-handed project. Just to get them started. What I'm going to do is I'm just going to plug the power supply in without anything else and see. There. And see what the voltages are with the power supply connected. And not connected to anything else, because that really doesn't make a heck of a lot of sense to me right there. But we'll find out. Alright, so everybody's disconnected. We're off up there. And which way did you go? Up. Okay. Alright. Everybody's disconnected. We'll turn you on. Yep, we got no fire. But now we can check our voltages here and see what we got going on. Everything else in the machine is dead. So let's see. Here's ground. Oops. I'm glad this meter will not blow up when you do that. So there's my in is 28 volts. There's my ground is 15 volts. And there's my output is 20 volts. The 15 volt ones, the negative 15, minus 14. Okay, so that means, what does that mean? That that's not the ground I want. Well, let's see, according to this, pins 3 and 5 on 3 and 4 are ground. Wow, snap. Minus 15, 15 volts, and 0. '39s are different than 38s. 44, 15, and 30. Alright, well, let's just take it with reference to ground. Output is 14.9. Output is minus 15. Output is 5. Alright, so we're all good. It's just they use the ground. The audio ground, okay. The audio ground is different than the ground, which in a lot of equipment it is that way. So we gotta put this guy back in here. Interesting. My fault. So basically what we're looking at, while we got this thing out, because it's really old, we're going to check these capacitors here. Probably should have done that while I had it out. Right. Make sure I get all my little plastic standoffs here. Alright. So my capacitors are there and there. Through a diode. Well, I guess we can try. I don't even know if this meter will read that high. I don't think so. Got a little bit of voltage left in it. I don't think this thing will read that high. Yeah, I'm pretty sure it won't. What are they? They are 30. Oh yeah, 3300s. It won't read that high. All right. Well. We'll put them on the little magic box. These are kind of a pain to get out. They're not, they don't exactly lock, but they got really short leads. And they're big. So you end up with a little too big for the solder suckers. There we go. Tip. At least the tip I got on here. Huh. This marked? Yes. Good. Alright, let's get the little magic box here. Let's see, I think I could do it this way. See what it says. Capacitor 45, no, that's wrong. 41 millifarads. Do I have my little pieces here someplace? I think. Whoops. Just turned off something. Okay, here we go. We want 1 and 3 on here. Alright. Now let's try it. I hate these little clips. I gotta find better clips someplace. Alright. Come on. And taking a while, but then I expect it to. Okay, 2800 at 0.66. Or 0.65, 1.9% V loss. 2800 is close enough to 33, so that's okay. It's only 0.66. Wow, that's pretty good. Well, fair. So let's take this one out. Okay. Wiggle it a little bit. There we go. This one was easy because the other one was right up next to it before and it was really hard to get out. Alright, so this one. You just want to do this as a matter of course, because if you don't, you know what's going to happen. 2933 at 0.69 ohms with a 1.5% V loss. That's good. And let's take this little guy out and check him. These guys are kind of old, so is just go through this step, especially if you're fixing it for someone else. Because the last thing you want to have happen is for them to come back and say, well, it worked for a week, or a month, or in the case of radio, a year, and then died. What do you tell me? Well, I was just too lazy to check the caps, and now they've leaked out completely, and I'm going to have to rebuild that little board for you, and it can't be done under warranty because it's been a year. They're not going to go for that, especially in radio. Oh, pulled off a trace. I love it. Why don't they make the holes just a little bit bigger so that the caps don't fit in there quite so ridiculously tight? Alright, this one says 2100 at 0.6, and it is a 2200. Alright, well, we're going to leave those guys alone. Try to get this guy flattened out enough to get him back in. Forgot to turn on my soldering gun. Soldering gun. Yeah, no, I don't use those. Well, not in electronics anyway. I've had to repair too much stuff from people using soldering guns to put things together. You really should have stopped using those back when when you quit doing tubes. That's all I'm saying. Okay, that's cleaned off enough. Let's get him back in here. There we go. They really cut these things short, I'm telling you. Just short. I guess they figured they only got approximately 1/4 of an inch down there, I guess. So we'll stick that in, push him up solid, make sure he's in there good, make sure he's in there right. Okay. Alright, there's one. Alright, these bolts are 33s, yes. Okay, plus over there. Don't get these wrong. And remember, they do go backwards to each other because one is plus. Voltage, the other one is minus voltage. Okay. When these go in, they actually do usually snap a little bit. And by the way, if you look at these on the bottom, one of them is painted black. Don't count on it, but usually one's painted black and that is the negative. But do not count on it. Remember, just because it's a standard doesn't mean everybody uses it. Which actually is just kind of exactly the opposite of what you should say. Alright. See, if you look at them, The plus of this one and the negative of this one are connected together in there. And that's the way it works for dual power supply. So we're going to heat this guy up, smash him down good. Same way with this side over here, because you got literally nothing to work with here as far as lead length. Well, that was interesting. Using the wrong ground. I should have thought of that when it was 15 volts. But hey, nobody's perfect, I guess. Well, that's why it appeared to work so well, actually. Okay. It's still semi-gooey, but let's give it some more, if I can find my stuff. Oh, stuff. Got too much junk piled up around here. Well, that didn't break on the way down, but didn't do it any good. Okay. There we go. Found my stuff. Doesn't take a tremendous amount. But you do want to do this because, remember, most of the time these things are in radio stations. And when you go put something in a radio station, it gets turned on, lined up, set the way the guy wants it, and left that way for years. It's just the way it works. And they do develop some heat. They're supposed to. I mean, you know, you're taking... This thing, what, was drawn 20 watts? Yep, so, you know, that's a fair amount of heat. And I'll clean this up a little bit. Yeah. There we go. Good enough. One of the things that's really kind of interesting is that in radio, probably in television too. I don't know because I don't really do TV. But in radio, when you've got something down, and you've got to fix it and get it out and get it back on the air, because A, you're off the air, B, the chief engineer's jumping all over you because that processor that died and you pulled out made us sound like we sound, and you you no longer sound like what he wants you to sound like, and as a result, you're always in a hurry. Come on. Everything's always an emergency. Let's get this one on here. And so you really don't have the luxury of spending much time cleaning anything like the PCB board when you get done with it. You know, getting rid of all your flux and that kind of stuff, because let's face it, you know, it's 5 minutes of not sounding, or an hour or 2 hours of not sounding good. This one doesn't want to seat You got to make sure they're seated, always. Come on, get in there without me breaking the IC, please. Nope, not yet. Alright, what is wrong? Okay, that should be. There we go. What was I saying? Oh yeah. Because you gotta. Everything is now instant emergency. So, if you ever see me forget to clean off a board, it's kinda just because, you know, it's almost a habit. Alright, now we are going to test these guys just to make sure that the outputs are not shorted. No, see? No, and no. Good. Always do that. Always, 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 always. Okay, we're going to put this one. Well, first of all, we're going to put the screws back in. Here they are. And they are these little guys here. Anyway, so if you ever see me put something back in without cleaning the board, cleaning the flux off the board, that's why. I try to be good, but sometimes I just forget. So, if we find out that the whole problem with this is because it was set up on 240 volts, that's going to be disturbing. Alright, because this thing is the only one that actually takes 5 volts, well, I don't know, maybe something else takes 5 volts up here, but I don't know what. This is all, there's no TTL, I mean, it's all plus or minus 15, but it's, okay. We'll test this one more time and make sure. On, nothing go poof. That's good. Voltage, ground, (14.9) minus 15, 5.0. All right. Okay, so we'll plug you here because this guy, I think, takes 5. That has an AT tiny and that in there, so it's got to take a 5 volts. I don't have the schematic for this particular version. I got a owner's manual, but that's about it. Got to get one. This guy, let's see. This guy was 3. He went there, and these two are the same, except one of them is shorter. Okay, and it went on there and over to, yeah, over to there. We kind of go by lead length here. Forgot. While we got it open, these dual gang pots, for the most part, they're pretty good. But if you look at it, you can see that they're open on the bottom here and a little hole on the side. So these are not sealed. So we're going to give them a little bit of a treatment. With some deoxit. I know everybody uses a different one. I use deoxit. I like it. I've been using it forever. That one I can't really get to, so I'll spray in the hole. These switches, not really. I've tried all kinds of ways to clean these switches, and it just doesn't happen. So if they're bad, you pretty much got to replace them. But they're pretty good. They work pretty well. So you don't really have all that problem. These feel good. Okay. Alright, and a little bit of lubricant. I wish these cans had a trigger down here. I keep going for it. It's not a trigger, it's up on the top. And I don't like it. But that's the way it is. We'll see how the pots are on the other channel when we get it in. These aren't the same, by the way, these channels. Need a rag. Okay. This one has the extra pot on it and control, and the push buttons. So no, it's not extra pot, just the push buttons. It's got the push buttons for stereo enhance, link and unlink, and that kind of stuff. Ooh, don't lose these. There. You really, 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 really don't want to lose these guys. Right there. Because you do, believe it or not, that little tiny bit of extra distance when you put this thing in makes all the difference in the world. Because when you screw it down, if you don't have that little extra distance, you'll put a bind on these pots and they won't turn right. I know it sounds ridiculous, but it's true. I've seen it many times. Everybody out of the pool. Come on. Except that bottom one. He kind of stays there. You gotta come up. Okay. And you actually have to plug this one in before you push the board down, because there ain't no room behind it if you don't. And then you got to manage to get all these LEDs in the holes at the same time. It's not quite as difficult as a 528E, because there just aren't quite as many. But there's enough to make it a trick. Fortunately, these are all little pointy ones that go in the, more or less go in the holes by themselves. When it hangs up, you got to find out which one is which that's holding you up. At this point, none. What the heck? Probably a switch then. Yep. Okay, that switch, that switch, that switch, that switch, up that switch. So you gotta make sure this little switch things go in the holes. Let's see, where are we? And the pots, and the switches, and the pots, and all of them. Look at it this, there's one. There we go. Phew! Uh-oh. Okay, there we go. That works. Alright. Plug you back in back here. Wasn't that entertaining? Oh, man. Yeah, just marvelous. Then you got to plug this little jumper here in right here. And boy, do you have to be careful with these guys, because those little pins will break off if you look at them crossways. Make sure you're not pinching anything. Like I said, there is no room back here at all Okay. There. Wow. Fun, fun, fun. All right, and then these got great big long ones that go down through here. Not pinching, not pinching, not pinching. All right. On the 528Es, I have fooled around with those for probably an hour at a time, just trying to get this all the LEDs back in after I messed with it for a long while, fixing it. You can't really take the board off, because when you take the board off, the top board that has LEDs on it, it has those ribbon cables that are soldered in. They don't unplug, and they're a pain. If you do it more than once, it's dead. All right, so we're on. We got power. We got output. Process in. Yep. Output level. Okay, good. All right, so everything is working. And our 5 volts is correct. So all of that for nothing. Well, we did check these guys. We did clean those pots down there. You know, we did check out the rest of it and make sure it looked okay. I guess now the only thing to do, we'll turn it on. We'll see if it needs to have the rest of the some of the capacitors replaced in here. Usually these don't. They got really good caps in them. They don't normally need the capacitors replaced. There are a few. There's not a lot, but I don't think I've ever seen one that needed caps replaced. As you've seen in my other videos, most of the time what needs to be replaced is these 3915s and 3914s. If this one doesn't, I'll be kind of surprised, but we'll see. All right, so we'll take you off of here. We'll plug you into there. Up to level. Okay, distortion, and I've been having problems. I think that thing needs to be fixed a little, because I can't really get a fantastic distortion readings. 0.6 is about what it's putting out, so that's which is what it's putting out. Interesting. Oh, wait a minute. I just noticed something. I got busted wire. I don't know if that will have anything to do with it or not, but we'll... Oh, this is that good. Nope, you can't melt that wire. I'll have to fix this, but I'm just going to tack this on here for right now. Ow, not that way. Okay. All right. Nah. That didn't help. I'm still getting about 0.253, about 0.26. Okay, that's fine. That's good. It doesn't need it. And the last check that we do is we take it and we plug it in to the scope. And you increase your volts per division. Anyway, you take it way out, and what you're doing is you're looking for RF on it. I'll show you here. If your caps if your bypass caps are bad, any place in the thing, sometimes they'll show up as RF on your output signal. And we'll turn this guy on and record. And as you can see, I am pulled out here to 0.2 microseconds, 10 millivolts per division, and there's no RF, there's just some noise on there. That's it. So if I take this down and take this back in, here comes my RF signal, or AF signal. So there's my audio frequency signal. So, you know, all I'm doing is measuring the output at very high frequencies, looking for some sort of RF. In the 528Es, if the filter, the little 4.7 microfarad filter, surface mount filter caps are bad, you'll get about 10 to 20 megahertz noise on your DC voltage. And trust me, it messes up everything. So, and it does. So, okay, so real quick, this thing's getting long again. All right, so I wanted to show you, if you pull these out here, if you don't put those little washers in back, when you do this and tighten these guys down, my little 3D printed nut drivers here, and tighten these guys down, when you go to turn them, they'll bind. I mean, and bind good. So you got to remember, if you fix something like this and it's got those little washers behind it, they're there for a reason. It doesn't look like it's that big of a deal when you think about it, but it is. So anyway, it looks like the whole problem with this thing was it was set up for 240 volts. But hey, we learned something. That's cool. I know how these things work, so I don't really have to go through a big alignment procedure. Well, there isn't much of an alignment procedure. The big magic stuff is done in here. And these guys are locked. And you really can't get to them. I'm going to go around and push down on the things, and I'm just going to check all of the functions and the lights to make sure, because what happens when the okay, got that bound. Yeah. Okay. There we go. I gotta loosen this up just a little bit. This whole board swings just a little bit on here. That's good. That's good. That's good. And that's good. All right. So, where was I? Now I forget. I got sidetracked. Oh, where was I? Oh, what happens is you've got, in these things, you've got 3915s and 3914s. The 3950 or 14s run, I believe it is the, the 3914s run the measurement for when you put this meter select in input and output and not in gain reduction. And then the 3915s are used to measure, or a combination of the 3915s and 14s are used to measure the gain reduction plus and minus. So it's that happens when these guys go out. That's what happens. So I guess still too tight. You don't want to have these too tight. What the heck? This is always a problem with these guys. If you don't get them on there straight, they bind on you too. So basically, I guess we'll go through and check. I probably will be editing a lot of this out, I think. I hope. I wonder if I got this hung up somewhere back here. I don't think so. Okay. We'll get this one over here. That doesn't feel right. And it's not. I did something wrong. I don't know, I did all this junk out here. Ha 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 ha. Okay. I just figured it out. Remember what I told you about those little... Come on. Wow. Yeah, thank you. About those little washers. Well, I goofed. And I put 2 on this first one, and none on this one. This one was fine, but this one was binding. So there you go. Proof. I knew I did something wrong because it just didn't feel right. I mean, it was binding badly on me. Remember, make sure that one's in back there. And now we got to go through this nonsense again. So your switches are good. Woo! That fell right in there. That almost never happens. Okay. Put this back together. And make sure you're not shorting anything here when you put your screws back in. Everything goes on the other side except this one. Yeah, we're good. Okay. Now we should be able to put these back on correctly. Boy. Careful attention to detail. Yeah, sure. Like I said, nobody's perfect. If I ever said I was sadly mistaken. Alright. Now, let's try the knob on that one. That was so goofy. Perfect. Yep. See? See? Do what I say, not as I do. It even felt better going on. You can tell they tighten up solid. They don't mush. Okay. So, what was I going to do? I was going to do something. Oh, yeah. So what we got to measure, or at least look at, on both channels here, is to make sure that your LEDs, let's bring you down a little bit here, see if I can show you how to do this. So your LEDs, not the DVG, that doesn't care. If I put this in input mode, then if I change my input, it should go down. It does. Okay? And if I put this in output mode and change this, yeah. What's that? That's the, yeah, output. It should go up and down, and it does. So that's correct. Now, if I put process in and put it on gain reduction, make sure, it doesn't matter what they do, as long as they do something, because when it comes down here and goes to the other side, and it goes to red, I forget how you get it to go to red. Oh, wait a minute. No. Yeah. See the red ones right there? Those are what is driven by the other side of the 3915. So you got to make sure that both of these work, or your display is incorrect. And I have seen many times these 3915s go out, or 14s and 15s go out. Okay, so now we're going to do it to this channel. Let's put the knobs back on because it's easier to run them. They just like to go bad on you. All right, so we'll put this meter in. Meter select is in input. That's good. And you see the red ones there? Well, okay. And we'll put it in output. Make sure we can change our output. We can. We'll put it in, whoops, gain reduction. And make sure that where gain reduction comes on, and there's one of your red ones. Right there, see? So, and it's working. Well, it's working because you can see it run up there. Uplink, buttons work. And if we turn this off and turn on our silent sensor light is working also right there. Yep. Groovy. Okay. So this one is functioning perfectly. Alright, let's take this down to, where is it? 0. That's the input. Output 5. Output 0. It is processing. And we're looking good. Alright, there we go. This one's fixed. And it was fixed about 5 minutes after I got it opened, but sometimes I'm just an idiot. So, I don't know. Oh well. Hey, if you like watching me make a fool out of myself, give me a thumbs up, you know, or just give it a thumbs up anyway. And don't forget to subscribe. That really helps. I'm up, I want to get up over 696. Been doing this for almost 3 years now. I'd like to get a few more subscribers if I could. Anyway, hey, thanks for watching, and we'll see you next time.